I don't have a mask. Yes, you do. I saw that paper once.
You're not going to wear that as a mask.
Yeah,
That is a
I
good
saw
mask.
that mask here. I
It makes
saw
you
it on the
look more
mountain. And
If you really don't have one, go to the office, go get one.
What's a mask?
If you want to pull it backwards so the top of your head, I can live with that.
Yes,
You're not wearing a ski mask for a mask.
Okay, you can wear a gas mask as a mask. It's got the
Yeah, I would have problems with a gas mask as well too.
You want to know something? There was a kid last year who actually brought a gas mask and wore it.
Connor was annoying it about.
Was their name Gavin?
No, his name is Connor. His name is Connor, and he's a psychopath.
Oh, and his Connor skates to get the other one. Connor skates to get the other one.
All right, time out. We'll turn anything. No, seriously, you don't have a mask. You can pull that. I don't care. You can wear it around your face, but not around your whole head.
You can't.
All right. Any questions? Obviously, you had the answers, but any questions on 11.3C? All right. You should all be very comfortable with the process, very fluent in how to get to the answers. We talked about, well, the rules, and then we said, well, great, the rules lead us down the path of understanding how to do it in a shorter manner just by looking at signs. And the only time we actually have to change signs is when there's two minuses next to each other. Now, we did spend, 5 whole days of talking about the rules and why things work. And then we eventually get to, how do people actually abstract numbers? Like, what's that process look like? And that homework right there was the culmination of all that stuff. All right, no questions? All right. I said from the start, I said that adding and subtracting was the hardest thing. So we're done with the hardest thing. The rest of the chapter, with exception of maybe one class, and it's the very last one. The rest of the chapter is a whole lot easier. This is literally maybe 10-minute class, what I'm about to show you. It's pretty simple. It's a different rule, though. The rules that apply for addition and subtraction do not apply to multiplication and division. We're going to begin our exploration of what happens when you multiply today. We'll do division tomorrow. What happens when you multiply two negatives that are two numbers that are opposite signs from each other. In other words, different signs. It is not the same rule as subtraction. The signs are different when you're doing adding. Right? You actually subtract the two numbers. When the signs are different when you multiply, there's no subtraction involved. All right. Grab one of the empty baskets. If one of them isn't empty, make it empty. And then walk around and collect the homework for me.
So how much work should we do?
Yes, 11.3C.
Mr. Chartier, here's doesn't have you down. You want to be going
I made really insanely good brownies. I got good brownies.
Right, so maybe you should pass them behind you. All right, here we go. Taking over the calendar. We got a lot to do in chapter 11. We will not finish chapter 11 before we get to state testing. Friday, they're supposed to give us a better briefing on what it will look like. I mean, I don't want to say anything other than the fact that this week right here will be the state testing. Last I heard, you're taking one test. It'll be the language arts test. I don't know what it's going to look like. What thing? More to follow. Hopefully, I'll give you a nice, clear picture on Monday of what it looks like. Yeah. You're still coming to school. You're still taking classes. You're going to be in a classroom with other kids like you, and they're going to be teaching you stuff. Okay? There will be homework, all that, yada, yada, yada. All right. Write down your homework. These are very quickly done. Very quickly done. Yeah, 2 through 24 even sounds like a lot. It's not. And they're all very quickly done. Yeah. I've not seen that one floating around, if that's what you're asking.
Found some homework. Don't know what it is for though.
I found homework. Someone else's.
Saturday.
Okay, the rules for multiplying require some explanation. The rules for addition, subtraction, right? I also had to explain to you why it was that it was true, the rules. Multiplication and division, those kind of seem really weird, so I spend a significant amount of time trying to get you to wrap your head around why these rules are such. Yeah. What? You didn't get one? Oh, that's right, because you were passing out. Duh. Sorry. All right. So this is called, the section is called products. Product being multiply of one negative factor. That means you're going to have 2 or 3 or 4 numbers multiplied together. One of them is going to be negative. All right. I think it's pretty simple today. You're going to learn the rule pretty quickly. If it was up to me, I probably would throw both rules at you at once. What happens when you multiply a positive times a negative? What happens when you multiply a negative times a negative? And then we would be done with it. The book chooses to do that in 2 separate lessons. So today we're going to get the lesson of what's a positive times a negative. Tomorrow we get negative times a negative. All right, recall from way back 3rd, 4th grade, when you're first introduced to this sucker right here, this is the multiplication symbol. And this is a very good symbol up until 7th grade. And then we stop using this because all of a sudden 7th grade is when we start seeing variables all the time. If you do it today, I'm going to be very upset. Do not do it today. Both of you. Okay. Up until 7th grade, this is our multiplication symbol. Beyond 7th grade, because it can be confused with the variable x, we don't use it as a multiplication symbol. What are the other things we use for multiplication symbol?
Dot and parentheses.
Dot and parentheses are the 2 main ways. By the way, once you get 9th grade and higher, parentheses are the primary way that multiplication is shown. It's not because you see parentheses that there's absolutely positively multiplication going on. It's just that if there is multiplication, they're going to use parentheses. And you're like, well, that seems silly. Why would they make it more complicated? It takes longer to put 2 parentheses than 1 single dot. Dots can be confused with decimal numbers. Dots are fun. You're going to see it this year and next year and into a little bit into high school. But we generally switch to parentheses. Parentheses can't be confused, and that's the primary reason why we use it. Second reason we like to use parentheses is because there's negatives involved. Okay? The 3 ways that you can use parentheses for multiplication is you put parentheses around the first number, you put parentheses around the second number, or you put parentheses around both numbers. All 3 of these mean the same thing, 6 times 5. Okay? We probably haven't seen this last one. Rarely used, but it can be done. The reason we use parentheses is now all of a sudden the numbers are not positive. They're a combination of positive and negative. This is not 6 minus 5. This is 6 times negative 5. Are you looking at the boards? Okay. The number one thing that a 7th grader will screw up is they look at this and they think, well, that's a 6 and a negative 5 opposite numbers. The answer is 1. No, this one's multiplication. Okay. Subtraction or multiplication? Subtraction or multiplication? 7th graders have a problem with what I highlighted there in yellow. Some, not all, right? They will look at these 3 in yellow, and instead of seeing multiplication, they will see subtraction. Well, let's further investigate that. I'll show you what subtraction looks like. Well, you just spent what, a whole week doing it. That's addition, right? This is adding a positive and a negative. This is what it will look like. Between the parentheses and the first number, you get a plus or a minus. Between the parentheses and the other number, you get a plus or a minus. Between the parentheses, you get a plus or a minus. All three of these are either addition or subtraction. Can you see it? By the way, this is what you did last night for homework. We switched to multiplication, so what do? We get rid of these symbols right here and squeeze the numbers together. When you squeeze the numbers together, you're saying multiplication. This is the hardest thing for 7th graders to wrap their head around. By the way, when we get to test day will be a combination of adding numbers, multiplying numbers, dividing numbers. Today, you're not going to make a mistake because, well, we're doing the section called multiplication. So you're obviously going to multiply the numbers. We get to test day, and I'll have somebody put the answer here for this middle one of +1. I have someone for the first one write -1. I have someone for the second one write -11. And you see why they would do that? If you're not careful, you can confuse adding, subtracting with multiplying. You won't confuse division, but you certainly, when you first start doing this, can confuse adding and subtracting with multiplying the two numbers. All right, anybody lost on that point? That's actually the hardest thing to do, is to visually see whether you're multiplying or whether you're adding. All right, or subtracting. All right, turns out that the rule for adding, subtracting is way harder than the rule for multiplying. The rule for multiplying is if you are multiplying two numbers that have different signs, a positive times a negative, or a negative times a positive. Anybody know? What's the rule? Anybody? Elizabeth? To multiply a positive times a negative or a negative times a positive? The answer is always
Positive.
The answer is always negative. Well, that's a claim. I better be able to prove that. Well, let me prove it to you. Okay. I'm going to claim that it doesn't matter what numbers you pick. Doesn't matter which one you have more of, positive or negatives, that if you multiply positive times a negative or a negative times a positive, the answer is always negative. Always. This is why it's an easy rule, because it's just always negative. Okay. That's tomorrow's class. All right. But why? Well, let's look at this, right? The first one is what times what?
2 times 3.
It's a positive times a positive, yes?
Yes.
But we better hope that the answer is,
6.
do you remember how this was explained to you way back in 3rd grade?
Absolutely not.
Okay, so you put like 3 little dots with like 2 columns and they can count them. That's how I was taught.
Isn't that how you were taught?
Yeah.
But they mainly just use Snap.
They said it's 2 groups of 3 dots and then count the dots. And they said, look, it's 6 dots. That's how it was taught to you. What's the second one say?
2 times -3.
2 times -3. So using the 3rd grade model, what are we going to do?
We're gonna make top.
We're going to do 2 groups of,
Negative.
we're going to do 2 groups of -3, then count dots. How many dots you got?
What? It's basically,
So a positive times a negative is a negative.
it's basically like just multiplying regular, we can just add negative.
Well, it's also got to do for this one, what's a negative times a positive? So, well, instead of saying,
You could flip it around.
I could say 3 groups of
Negative.
negative 2. I could also say, do you remember what the symbol is called?
Subtraction.
Negative.
And I also said something else. What's the opposite of 6?
Negative.
So I could say this is the opposite of 2. Right? The opposite of 2 is negative 2, right? So I could use, if I chose, I could choose the word opposite. Or I can do what you guys said, which is just flip the things around. We could do 3 groups of -2, because remember, multiplication is commutative. 2 times 3 is the same as 3 times 2, so I can flip them around. So flip them around. That would be 3 groups of, okay, so we'll do 3 groups of -2. We still get,
Negative 6.
so a negative times a positive is
That's correct.
a positive times a negative is I just proved it to you. Then,
Okay, so if you have 0 divided by a negative, or multiplied by a negative.
what's 0 times anything?
0, but there's no
Stick to that rule.
0, so therefore.
Stick to that rule. 0 times anything is 0. He's doing his homework. All right, write this down, please. Box 1. This is the rule. The rule for if you have different signs. Remember, you can't multiply 3 numbers at once. You can only do 2 numbers at once. But if you're multiplying two numbers and you have different signs, one's positive, one's negative, or one's negative, one's positive, the answer is always negative. The answer is always negative. I'll let you choose to write that how you would like to write that. That's how I write it. Way easier than adding, subtracting. I don't have to think, wait, how many signs do I have? Which one do I have more of? The answer is always negative. Now be careful. What Pierce said, hey, what happens if you have a negative times a negative? We'll talk about that tomorrow.
That's
Okay.
the same as a positive times a positive.
Turns out that's true, but I got to prove that one as well too. But we'll talk about that tomorrow. Positive times a negative or a negative times a positive is a negative. Class dismissed. That's it. Literally. The homework is multiplying numbers. You already know how to multiply numbers. If you're multiplying a positive times a negative, the answer is negative. There's nothing else. I can't make it any more complicated.
Yeah, I'm sure you said.
Well, I made it complicated for Ben. I said multiply by 0, and it caused him to say, well, what in the world will happen? Because he's thinking, could you get a negative 0 or positive 0? Remember, 0 is the only number that has no sign. It's not positive, it's not negative, it's just 0. It's the absence of value. Yeah. I don't. Right? How about we continue our search process before we admit defeat? Okay. As always, this first time that you see negative numbers, instead of putting the negative in the middle, they put the negative above and to the left. Okay? You're going to see that for this chapter, and then we will never see it again, ever. The negative will always be in the middle. Okay? Hey, what's 3 times 4? What's a positive times a negative? So the answer is, I can't make it that complicated. What's 4 times 5? What's a negative times a positive? So what's the answer? This is why no one has problems with, no one has problems with multiplication. Can you screw it up? Sure. You're not paying attention. Tomorrow is the one that most people screw up. When one's positive and one's negative, I rarely see a kid make a mistake. We get to high school and there's lots of negatives. There's 13 negatives floating around because you're multiplying 13 numbers together. We'll see mistakes, but it's because there's so much multiplication involved. That's usually what the mistake is. But the rule itself is pretty simple. That is literally it. Okay. So all by yourself, do box 2. Should take you all of 5 seconds.
Or you could be the big boy and you could go and do your homework.
Well, let's run through all the examples first, and then we'll have plenty of time to get started on homework today. Was that his book, or you're just writing from yours? All right, I said it's going to take you 10 seconds. Macy, the answer to the first one is? Well, I can't make it any more challenging than that. Josh, the second one is?
Wait a minute.
Josh, they're all going to be negative. Except for like.
Elizabeth, you got to keep some of those comments to yourself. But I agree.
What'd you say?
And it wasn't really funny. It was kind of rude, but it did make me laugh. Josh, the answer is -49. Very nice. Ben, the last one is 0. 0 times anything, whether it's positive or negative, is 0. All right. Shh. Simplify just means do the math. Find the product means, well, it means that there's no possibility of adding, subtracting, or division. There's just multiplication involved. All right, another 10 seconds. Box 3, go. I said that at the start. All right, Keegan, first one, the answer is? -90. Mr. Chartier's room. I do. It's coming your way. All right. Guess what I did wrong?
You didn't know it isn't.
I'm going to blame you guys for not reminding me. I don't want to take responsibility for my faults. All right, listen up. Elijah. Kira. Gavin.
Give me the good food.
Hey, I can't hear if you guys are talking.
Sadly.
Kaylin. Matt. Malachi.
Oh.
Elizabeth.
No.
Lily.
No.
Keegan. Bo.
Yes.
Nick.
Yeah.
Oh.
Jaden.
Yes, please.
Riley. Macy. King. Ace. Xavier. Josh.
Cheers. Yes.
Pierce. Jameson. Abby. Ben. Felicity. Jasmine. Caden. And Noah. Same as yesterday. 15. Bo. Hey, Bo, seriously. I'm very forgetful. Don't let me forget.
He's gonna let you forget.
If I remind you, could I take it down?
Bo's pretty good at remembering things.
He's nice. Didn't remind you
Doll hair.
Well, we're all a little bit slow simply because it's spring, coming back from spring break.
It was a week ago.
I'm just slow because I'm
I forgot to do my last song.
Yep, so did I.
Well, you're gonna have time because we're just about done right now.
We went over the class on Tuesday. That's what it said. We already
All right, back at it after a momentary delay. We were on Keegan. Answer Keegan is
Negative 90.
negative 90. Very good. Jasmine, the middle one, the answer is.
6, 9.
Do we need to do more of these?
No.
All right.
Well, I guess.
Wait, what about?
More complicated ones. They get more complicated because there will be more than 2 numbers multiplied together. We did this for adding, subtracting, and I said you can only add or subtract how many numbers at one time?
1.
2 numbers at one time. The same rule applies for multiplication. As always, when we do PEMDAS, it does not mean, Malachi, that we do multiplication and division. We do all multiplication first and then division. What does it really mean? We go left to right, always. We get rid of all multiplication and division going from left to right, and then we get rid of all addition and subtraction going from left to right. So going from left to right, hey, look, we got parentheses. It even tells us, do what's inside the parentheses first. Occasionally, there might not be any parentheses. If there's no parentheses, you must go left to right. If there are parentheses, do what's inside the parentheses first. By the way, if there's just multiplication, it doesn't matter the order. So here we go. 3 times negative 4 is?
Wow.
That's the first mistake in class, right? Using PEMDAS, we do parentheses first, negative 12. What's negative 12 times 2?
Negative 20.
All right, well, that's how you do the more complicated ones. I didn't say the challenging hard ones. I just said the more complicated
Here, can we
ones.
see the challenging hard ones then?
There are none for this. It doesn't get challenging.
Except if you did.
Except if you fail the.
Okay, so, yeah, but that's not challenging of what the answer is, positive or negative. That's just challenging for the computations themselves. I'm not sure why people have calculators in your hand. The numbers are not that challenging.
Yes.
Oh, yeah? 482 times 505.
Yeah, but what's on the board is not that complicated. All right,
Because I'm not doing more.
all right, up here, inside parentheses, what do we got?
Negative 6.
Okay, so what's inside the parentheses turns into negative 6. 5 times negative 6 is,
Negative 30.
all right.
8. Negative 14 times.
Oh, no.
Oh no. Dude, no, I'm gonna be doing that to you like the whole class period, okay? Oh. Dude, Nick, remember Millennium?
It's gonna become my
I saw one.
Oh, God.
6.
Oh,
16 bits.
Oh my god! Dude, the other class is gonna ask what we're doing. Oh my god.
Does it ever end?
Please do not end it.
Mr. Shardy, we need infinity. Why?
No, that's it. All right.
Dang.
Do these last three and we'll call it a day.
Oh,
And then can we watch Mexican soap operas?
No.
Are you doing?
Say again? See what's inside the front?
Dude, it's probably loading.
Yeah, I know, but why is it like 17 divided by 10 times?
They just gave you two
It's the same problem.
Right, so guess what they're trying to
32.
Add this. Yeah, I know that.
Just be careful because these are
Which one?
be careful. Just be careful. What's inside the parentheses first? Hold on.
What?
Wait a minute.
All right, are we good? Are we done? Quiet, please.
No, the homework is
All right,
challenge.
hush. Riley, first one. What do we get? Final answer. Let's see. 4 times -3 is -12. -12 times 2 is in fact -24. Very good.
She said 21.
I thought she said 24.
21.
All right, middle one, Nick. What's final answer?
-35.
-35 is correct. And last but not least, Noah, last one. Negative what? -32. Very good. Questions on anything that we did today? Hey, I'm looking at my clock. I got 20 minutes. There is not a single person here. Seriously, I don't want to see calculators. Okay, it is too much of a I don't know. Because the numbers are a little bit larger, you're immediately going to want to grab your calculator. I want you to do it by hand. If you get done at the very end, then you want to pull your calculator out, absolutely positively. But I don't want to see calculators until you are done. You need to do the process of multiplying. Lily, you may. Yes.
Yay!
There's 4, 16, 32, 64, 128.
That looks like a million.
Honestly, what were you guys doing? We were watching
512. The 1,024.
48 bits.
1,024.
It's so beautiful. So
2,048.
Lily, sharpen your pencil. Go back to your seat.
Paint wrapping.
Somebody spent their afternoon making that. I don't know who it was.
that would suck.
All right, let's go. Get your books out. Get your homework
I made
done.
Patrick say
I stuck my head.
When it's done, start working on your poem again. Squeeze around with someone who has their book.
I don't have my book here.
Got this under control?
No.
Positive times a negative is always a. You got it.
Wait, is it?
I forgot how to do this.
Mr. Shardy.
Ooh, 20 is a 22 is a cheeky one. 0.
Oh, yeah.
All right, if you are done with your math, you should be working on your poem or anything else in the class.
What's 7 times 7 is?
Come here.
Oh, these are what she does.
22 is negative 0. Times 7.
I don't remember how to say. Yeah, the answer's 0.
Anything times 0 is always 0, no matter how many times you multiply it.
He was saying this at the end is 7 times 7.
Did you correct him?
Yes.
All right.
So I just did.
All right, e-learners, any questions? We will end the video right now. If you do have any questions, send me a chat or email.
It looks like a